everybody for coming. My talk today is methods received, lessons learned while scaling RabbitMQ in a high growth environment. Long story short, this talk's really about, we adopted RabbitMQ when we just had dozens of customers, and then when I left the company, we had millions of customers. So lots and lots of pressure, a lot of lesson learned. So before I get started, just a little bit about myself, just who I am. My name is James Carr. I am founder and fractional CTO with Starfish Prime. Basically work with teams, helping them figure out a lot of things with message-driven architecture, as well as engineering org structures, helping seed-funded startups start scaling out. And previously, before I kind of went freelance, I've led SRE teams, platform teams, and product engineering teams. And with that, I spent a lot of my time with RabbitMQ. Worked with a really popular site that did vehicle history reports, and we used RabbitMQ for processing data from dealers and getting it in front of consumers. Also spent the last 8 years before that, or after that, kind of as a startup where basically we were integrating multiple APIs together. It basically allowed, non-developers to build automations with all of the services that they use. And of course, I've spent way too much time wrangling RabbitMQ issues late at night, dealing with weird cluster problems. It's like, hey, how come RabbitMQ has just stopped? Why is it messed up? So that's the agenda for today. I was going to take one of the products that I worked with a significant amount of time and just kind of give a quick overview of it and the architecture behind it, just kind of provide some context. And then from there, when I talk about some outages, I might point out a few outages that I've dealt with that were memorable. And then from there, just the tips and tricks that we learned from those incidents, as well as things to help you with performance tuning, monitoring, and alerting. And when I talk about the product a little bit, like I said, we learned a lot of hard lessons. We had, I think when everybody starts with RabbitMQ, it's easy to just get going. But then once you start getting a significant amount of traffic, that's when you start learning a lot of things, right? And so if I get started, just a little bit about the architecture and product overview. So the actual application, like I said, is it allowed non-developers to basically integrate the services that they work with. So a classic example, you have a marketer, they're using Facebook leads. When a new lead comes in, they want to broadcast it out on Slack, and then they also want to add that person's email to their mailing list. So pretty straightforward feature. So somebody who's a user of the website will set up this up, and then this will just run. It'll just process every single time new leads come through, whatever marketing campaigns they have, etc. And developers use the website too, so it's pretty useful for any time you want to glue multiple services together. And so a little bit about the architecture. This is extremely simplified. You notice I didn't capture exchanges or anything like that. These are just the basic high-level building blocks. But this website was basically completely driven by RabbitMQ. Everything that ran through it was a task. And when you integrate with APIs, you really have two classifications of tasks. You'll have things that trigger a workflow, and then you also have actions where you're writing data to another API, or you're searching a data and getting results back and doing things further in the workflow. And within the triggers, we actually had two kinds of triggers. You have APIs that it just has a list of, say, invoices. And so you have to pull it periodically in order to detect new things, because new invoices won't show up in the API list until you read it a second time, third time, fourth time. So that whole process has a scheduler. And basically say, hey, every 5 minutes, every 15 minutes, pull this API, detect if there's anything new, and then trigger it. And then same thing for webhooks. Webhooks either came in two flavors. They were either a static webhook that you just plug into a website, and then you configure the other application and start sending data to it. Or they had subscription webhooks where you're working with the website and you set up an API, and you say, hey, I want to listen to new invoices that come in. And basically it'll create a subscription webhook and basically send webhooks to the application that's hosting this anytime new invoices get created. And so both those processes were pretty straightforward. You had a scheduler that would run periodically. It would dump like the details about the APIs that needed to be pulled, and you had pulling workers in the background. They were basically just pulling APIs and detecting new things, triggering them. Same thing with webhooks. We had something that was ingesting webhooks on the front end, queuing those messages up, and then back-end workers that were basically validating them, processing them, all those things. And then lastly, you had the actions. The actions, since there's multi-steps, like you notice there's like multiple workflows, like a message would get published to Rabbit that would actually trigger a action that would like write to an API, then get the result back, and then it would just like publish to Rabbit again, and then you have like something further in the chain handling it until I've reached the end of the actual workflow. And so, like I said, the thing I learned there is RabbitMQ is really easy to set up. When I worked at the vehicle history company, we set up a cluster, we read all the RabbitMQ HA documentation. We lucked out. We just launched a 5-node cluster and it worked for like ever. Like I think, long after I left the company, I was talking to somebody, they were like, oh yeah, we still use that 9 years later. So it was like surprising, but it was also because their workloads were different. They weren't really, even if they scaled, they remained very consistent. So as an example, right? We just ran it, it just worked, didn't have to think about it again. But that's the other thing I learned at the second job that I had was that in the beginning, everything seems to just work as expected. But then as you start pumping more volume and more traffic through your brokers, you start to discover more and more misconfigurations, either at the client side, the broker side, the publishers, consumers. There's like all kinds of different areas where you discover misconfigurations. And my worst one that I used to deal with a lot was RabbitMQ just stops. Like, for some reason, queues start backing up, and they're just not getting delivered, even though the consumers were listening. We'd have like a cluster where one node just suddenly stops. It just doesn't process anything. And just for some context here too, when I'm talking about this, we were using RabbitMQ from, and they still do, but when I was there, they were using RabbitMQ from 2013 to 2020. So obviously a lot of things have been fixed since then. But even with modern, even if you upgrade Rabbit, I'm sure you're going to encounter some kind of bugs or defects, right? And so incidents come with growth, like once we started hitting those different milestones, started getting more and more daily active users, we had more and more incidents. Either we discovered our high water mark was too low, we weren't gracefully handling back pressure. For that back pressure is a perfect example, is like, you suddenly get slammed with a bunch of webhooks, which could be like a surge. And you don't handle that back pressure. And if you like set your system up to be scalable like we had, like consumers just scale it out, they get to a certain point where obviously the database is going to be too slow or Memcache is going to be too slow. And then now, because of that, RabbitMQ is too slow. Also network partitions that you just don't account for, and just generally bad queue settings. So, like I mentioned, the common causes for us was that people would like set up like the webhook integrations, for example, within the apps that they were using, and then they would like do some kind of process where it would slam us with the webhooks, like they're doing some kind of update process or something like that. And it would just be a surge, and then that surge would like, all of a sudden consumers would be just dead in the water. Like we wouldn't be able to figure out why. We weren't be able to figure out like why they were slowing down, and the queues would start backing up. And before you know it, Rabbit falls over because the queue gets too large. So just bad times all around. And it's like something I always like to talk about with Rabbit, because like if like every single time we had a RabbitMQ outage, it was we always made it worse trying to resolve the incident. Like I remember we had an issue where RabbitMQ had stopped. It wasn't, that one node was down. It was causing mirrored queues to not be synced, which don't use mirrored queues, but that's another story. And like one of my teammates were like looking up, like if anybody felt like seeing these same log messages, and they were like, oh, you just restart the node and it'll start processing again. So we restart the node and then come to discover that the EC2 instance was set up with an instance only store. So like everything that was in the queues on that box were just gone. But don't panic. I think, there's a lot that, you can improve with the way you use Rabbit. Like definitely read all the material out there. Measure metrics is the most important thing. If you're not measuring any metrics around Rabbit, you should start. And then you also need to really dig down and figure out which metrics are very important for you. Grafana, Datadog, they all provide default dashboards, which are a great starting point. But almost all the time that we had incidents, those dashboards themselves would only be lagging indicators. They would basically picking up things when they were a little too late. And that might have changed in the last 3 years, just FYI. But like some important things I think that are really important to measure is obviously queue depth. Like you want to measure like, how fast is it growing, as well as like what's their backlog. And you want to be able to like also know like what's the limits of your queues, like where do you need to cap them at? At what point are they going to be too long? And then queue consumer utilization is probably the biggest one. And the reason for that is anytime your consumers are under 100%, that's bad. Like anytime they fall below 100. And so you want to really track that, capture it, and then understand it. Publish rate, ACK rate, connections and channels. These are all things that you should be tracking because, for example, you could start leaking connections. You could be using too many channels. There's like a lot of different things that become very obvious when you monitor those. And then, of course, export them to the platform of your choice. Whether you're using Grafana, Datadog, New Relic, whatever is like most relevant for you. But keep in mind, metrics aren't free. I think another incident that we ended up having was that RabbitMQ was just coming under pressure, like it was like CPU is spiking, we couldn't really understand why. And while we were scraping the metrics every second, and which at a smaller scale, it's fine. It doesn't do anything. Once you start getting to a really large scale, it does. Like one of my teammates was like, well, if you just try doing 30 seconds, and right then the CPU dropped. And it's like, okay, let's just do it like every 60 seconds. And at that point, CPU was back to normal, so we had to like settle on a 60-second window, which, although you might want that 1 second visibility, 60 seconds is good enough for the most part. And let's see, I think the other thing too is like, metrics are not just for observability, but they're also to inform your systems as well. Like we used those metrics to figure out like when to scale things out better, when we can like, be able to contract consumers, things like that. Another thing we ended up adopting early on was sharded queues. This was a performance hit that we were starting to have from having a single queue. We had like 70 consumers on that queue. And so one of the things we ended up discovering is like, well, we could just split our queues up and then basically have as many as there are cores on the instance. And then from there, we were able to get a lot better queue utilization. And our solution at the time was homegrown because the consistent hash exchange and the sharded queue plugin didn't exist at the time. Those are two things you should definitely look into. I mean, they're not plugins anymore. They're actually part of RabbitMQ core. But we just had our own solution that used routing keys to like figure out which queue to go to, and then a randomized like consistent hash in the publisher side. Also, know your client library really well, and I think this is a really important part. We were using Celery, and there's a lot of default configurations that were just like out of the box not good for you. I think one of the things that really bit us was, for example, there was no heartbeats enabled by default. And so knowing your configuration details is really, really important. Then if you could set up distributed tracing, that's even better. Like, tracing is good, but like actually being able to see in a trace that this publisher published this message, and then this consumer picked that message up, and being able to see that visualized within Datadog or Honeycomb or whatever you're using is just, it's amazing. It's easy to track things down a lot better. And it's just your toolkit. You need to understand it really well. You need to check the source code out, contribute back to it if you can. I think it's just really, really important to know your library extremely well. And most importantly, I think back pressure is the most important thing that you really have to think about. You got to think about how you're going to, accommodate it. And, like what are you going to do when things are like pressured up if you can only scale out so much until other resources come under contention, right? So you have to think of ways that you can like kind of push messages off and set them to the side. We leverage feature toggles pretty heavily. So for example, if RabbitMQ is down, if it's having an incident, we could just like click that toggle and then just like shunt those messages somewhere else until it came back up. And it's also something to also think about too is just back pressure strategies. there's like three core strategies I think they're always important for when you're dealing with, any kind of RabbitMQ incident or backups. You're either going to want to find a way to control your producers, slow your producers down. We did this by having all our producers actually had like a journal, like it was locally based, that we'd write to, and then that would publish to RabbitMQ. Don't think that was the greatest solution, but it worked. It was a solution that came up under the gun while dealing with messages backed up a little too much. Another situation is like your publishers can be just slowed down artificially, or you can also, like I said, use feature toggles and say, okay, let's start shunting all these messages into SQS, Dynamo, or just like some other data store that you can play recovery from later. Another one is buffering messages. That's what I was talking about. We'd buffer messages up on the publishers, and then we'd like go ahead and push them through. And then lastly, and this is a greatest one, but sometimes you have to drop messages. We had one queue for the polling workers. Since they polled every 15 minutes, every 5 minutes, we could just set a TTL on them. And basically it didn't matter because if they got missed, next time they came through, they would like detect everything that was missed since like the last like 30 minutes. But that's a very simplification though. There's like a lot of mechanics we came into it with like to have it make sure that no polls were actually missed either. And then I think things that are configurations that really matter is like you want to really, really pay attention if you're using a cluster, what your partitioning handling strategy is. Because RabbitMQ comes with two, they're auto heal and pause minority. Neither of them are perfect though. Like one you're going to have consistency, another one you're going to have one you're going to have consistency, the other one you're going to have durability. Neither are perfect though. So they understand what their trade-offs are and just make sure that you're okay with the trade-offs with regards to your workloads. Also, high watermark is probably one of the most important ones to make sure you configure. The default's a little low, you kind of want to raise it a little bit. But then also think about like making sure it stays under that high watermark. You're like always going to want to keep your queues to like a nice fixed size, make sure you have like really good consumer utilization. In process level tuning, making sure you have all those right process metrics. There's plenty of documentation out there. Cloud AMQP has an awesome 5-part series where they kind of go into like all the process tuning you should do. And then for me, like one of the most important was enable TCP keep alive in client heartbeats. That one kind of showed its way in a funny way that our whole system worked fine. We deployed multiple times per day. And then once like a holiday came and nobody was deploying, queues suddenly started backing up. We'd go out there and we'd find like loads and loads of workers that were almost like at 10% CPU, 5% CPU. It's like, what is going on? And it turns out that those connections were closing from being running too long, and we were never seeing them because we deployed so much. So you want to make sure that you have those enabled, that you have some way to test them out. Then finally, I think a confession. We actually ended up ditching our RabbitMQ cluster. We used our cluster from, like I said, 2012 all the way up until 2019. And then in 2019, we had the most horrible incident. It was just a huge bloodbath. It was just like the whole cluster was failed. We had to launch a new one. We had to migrate over to it. And from then, like in our post-mortem, one of the ideas we came up with was to just use standalone brokers and distribute them across like availability zones and eventually across pods in Kubernetes. And I think that really worked well. Performance increased significantly after we did that. And then also it helped move us from a very centralized structure to a more distributed structure. At that time, we didn't have any kind of division of the workloads going through our cluster. We just had the RabbitMQ cluster, and we had a backup, and that was it. So like all the applications talked to it. But once we did this route, it also allowed us to separate out and have like different applications, different workflows, had their own brokers basically. And once you automate broker replacement, it makes it a really easy choice. We went from people being terrified of RabbitMQ to it's just a chore. Like 1 hour, go through and you just run a few Terraform applies and replace each broker. So some key takeaways I think are important. You definitely want to make sure you have the right level of observability. And when I say that too, it's like the default dashboards are great, but you really have to understand what your workloads are, what kind of the key metrics you want to track around your workloads, and make sure you have dashboards around those, make sure you have the right tuning around them. And then, like, that goes hand in hand with understanding your workloads deeply. Like, when we set up RabbitMQ, we'd run performance benchmarks on it and show how great the performance was. When we actually got in production, the nature of the workflows were obviously different because you're just flooding it with test messages before when you're stress testing it. So you got to understand your workloads, because how performant your RabbitMQ broker is going to be dependent on what kind of workloads you have. And then don't have queues that are too long or too large. Like, whenever we'd have queues start backing up past 1 million, we knew we were in trouble. We had to act fast or things were going to start falling apart. And so, like I said, you want to control your publishers and do things like that. There's all kinds of strategies you can use there. For example, what we do is when we had a backlog that got too big, we'd stagger the pulling tasks. So it's do a bunch of them in one spurt, and then we'd just do a little bit. And then eventually, as everything recovered, it would level out. But we just had a staggering algorithm to avoid overloading brokers. And then lastly, make sure you have a place for messages to go. This sounds obvious, but RabbitMQ is the one that's basically routing off your messages. If it goes down, you gotta make sure you have somewhere to go, whether you're buffering them locally, whether you're putting them into an alternative store, just some kind of mechanism where you can have some replay and play back. That's it. I want to thank you all for your time, and if you have any questions, feel free to let me know.